Hi guys, we want to look at this problem. When x approaches infinity, we want to write this Riemann sum as a definite integral. Once you know how to do that, probably this is just a piece of cake. This problem here, compare these two, I just simply add a function here, sine of this guy. If there's no such a function there, this is just itself, right? So let's first look at this. First of all, you already know that this is a right Riemann sum, and then you want to figure out, so when we discuss Riemann sum, we say in some interval a to b, we are going to divide that into n intervals. That's why you see n there, n there. And then how do we determine the width of each subinterval? It's going to be b minus a over n. So each subinterval, that's the length. That's the width. And when you look at the right Riemann sum, say suppose this is function, you're going to use the right endpoints of each interval to form a rectangle, right? To form a rectangle and so on and so forth. Here you use right endpoint and so on and so forth. So you will have a lot of a lot of rectangles to add. That's where this summation is. So with that, when I look at this summation, I quickly recognize 3 over n actually supposed to be my width, the width of each subinterval. So this is gonna be my width, delta x, right? That's the width, because it's a fixed constant, so it can be actually factored out from your summation. That's why it is moved up to the front. Now the next thing that I'm gonna do is I just look at when I is 1, what is my first like sine of x, right? Sine of what value? And this supposedly when I is 1, that's the first right endpoint, the subinterval, the first right endpoint for the first interval. Let's take a look at that. When I is 1, this is going to be 3 plus 3 times 1 over n, which is 3 plus 3 over n, right? So this actually gives me a very good idea where my interval begins, because this says it looks like my interval begins with 3. I'm going to try another one. If this is 3, we do know that if this is delta x, then the interval, the length of the interval is supposed to be 3, because when you find the length of each interval, it's b minus a divided by n, right? So therefore I know my length of the interval should be 3. The total should be 3. Divide that into n intervals. So now, so I do know that it begins with 3. And with that, I quickly know it's going to be n at 6, because what's the length of the interval? 3. So if you start with 3, then it must end at 6, right? So that the total length is 3. When you divide that into n subintervals, each interval has width 3 over n. It matches that perfectly. So because this is right Riemann sum, this is supposed to be the right endpoint of my first interval, which is 3 plus 3 over n, which is exactly what it is. Now when I is 2, 3 plus 3 times 2 over n, which is 3 plus 2 times 3 over n. I would like to rewrite it that way. And take a look at what we have here. This is 3 plus 3 over n, and the width of its second interval is 3 over n again. So what's the endpoint of the second interval, the right endpoint of the second interval? It's going to be 3 plus twice of the 3 over n, because there's another 3 over n there, right? So which perfectly matches. When n is 2, that's the second right endpoint. So with that, you do know that this summation actually is a summation of sine 3 plus 3 I over n times the width, which is 3 over n, I from 1 to n. This is the Riemann sum for sine function with each interval 3 over n over the span of the interval over this interval 3 to 6. So over the interval 3 to 6. Now when you apply the limits when n approaches infinity, when I see these two, that means that's my integral symbol. We just discussed that the interval is 3 to 6. Again, if you missed that piece of information, why 3 to 6, please go back to the video and then begin by how we identify 3 over n as b minus a over n. And the function here is going to be sine. That's the grid point, right? The grid point is my x. It starts with the first grid point, the right endpoint of the first interval. So don't get confused by 3 plus 3i over n. That's where your grid point is. When I is 1, that's the first grid point. That's your simply the x chosen from the first interval. When I is 2, that's your x chosen from the second interval. So that would be just your x here. And this is, this actually, if you remember, this is delta x. Delta x is 3 over n. So that becomes your dx. Okay, so that's how I would rewrite this into definite integral. Now, time to take a look at this one. We actually discussed this identical problem, but without the sign, right? So with the previous discussion, we do know that this guy can be written as 3 plus 3i over n times 3 over n. This is just constant with respect to I. There's no I at all. It can be moved into the summation. And this guy is exactly my delta x. If you remember, that's the width of each subinterval. And then we also discussed the interval that we talk about is from 3 to 6. Quickly review why begin with 3. When I is 1, it's 3 plus 3 over n. That's the, each interval is 3 over n. So that's your first right endpoint of the first interval. So this is just your right endpoint, right? Right endpoint. So that's basically your, we call that as x. That's the x chosen from the first interval. So now this is delta x. This is simply your x, basically. When you apply the limit n approaches infinity, again, whenever you see these two together, that's your integral symbol. And then how do you figure out the starting and end points? That's why you plug in the I in here to see what is the first number, right? You plug in I, 3 plus 3 over n, that's the first right end point, and therefore the interval should start with 3. Ends with 6. How do we know ends with 6? This is the length. This is the length. For the interval to be 3, when you begin with 3, it must end 6. So there were 3 to 6. And this is simply just x. This is the dx. Hopefully this helps. These are not easy questions, but certainly they are good problems to help you understand the Riemann sum, the definite integral, and how do you convert these back and forth.